Alright, in this video we're going to look at some examples of arithmetic progression problems. First, we're going to start by just listing the formulas we derived earlier. So this first one is the formula for the nth term of an AP, and then these two are the sum formulas for the first n terms. So the first one, if we know the first and the last term, and the second one, if we only know the first term and the common difference. All right, so in number one, we're going to find the formula for the nth term of a given arithmetic sequence. Then we're going to use the formula to find the term that they're going to indicate. Then we're going to find the sum of the first n terms, which is going to be indicated as well. We are going to do the first two, and then we're going to give you the opportunity to try the last two. Right, so let's get going. So in the first one, we have the first four terms given for 10, 16, and 22. Sequence continues like that. So the first term is going to be 4. We just read it out from the given terms. Then the common difference is going to be second term minus first term. So the common difference is 6. So we said once we know T1 and D, we can find most things for an AP. So Tn is T1 plus n minus 1D. T1 is 4. D is 6. So if we remove brackets here, it is going to be 4 plus 6n minus 6. So this is going to be 6n minus 2. Now here the formula we can always check by plugging in n equals 1. Plug in n equals 1, it should give us the first term of the progression. So here it's going to be 6 times 1 minus 2. So it's 6 minus 2 is 4. So it looks like this formula is good. All right, then in part B, we want to find term number 90 in this example. So we work that out by simply plugging n is 90 here. So this is going to be 6 times 90 minus 2. Then if you punch that in the calculator, that is going to give us 538. In C, want the sum of the first 100 terms of this sequence. So 4 plus 10 plus 16 all the way to 100 terms. All right, so we know the first term, we know T1, but we know D, we don't know the last term. So for that reason, we are going to use the formula that does not involve the last term. So 2T1 plus n minus 1D here. Okay, so for S100, so every n is going to be replaced by 100. T1 is 4. And then this is going to be 100 minus 1, which is 99. D is 6. Right, and then if we punch this in the calculator, it's going to give us 33. 3,100. All right, so that's the first one. In part 2, we are given the first 3 terms of an arithmetic sequence as 10, 2, and minus 6. So that means T1 is 10 here. D is going to be 2 minus 10. So D is negative 8. So this time Tn is going to be T1 plus n minus 1 times D. So this is 10 minus 8n plus 8. So notice that negative times negative here is going to give us positive. So it's going to be 18 minus 8n. So again, if we just plug in n is 1 here, it will give us 18 minus 8, which is 10, which is the first term there. So that looks like that formula is good. Okay, then in part B, we want term number 75. Okay, so it's part B. Term number 75 there. So we're simply going to plug in 75 in the formula just derived. 18 minus 8 times 75. If we punch this in the calculator, it's going to give us minus 582. Then in part C, we want the sum of the first 70 terms. So again, if we use the second formula, going to be 70 over 2 there. 2 times 10. 70 minus 1 times negative 8. This we can punch in the calculator. It's going to give us 18,620 negative. All right. So then in a moment, we'll give you a chance to have a go at part 7 and part 8. Right now, I'm going to jump to number 3. Okay. So in number 3, all right, number 3, we're given that the 6th term of an AP is 21. So it's the first piece of information we have. Then we are told that the sum of the first 17 terms is 0. So we're going to have to use those pieces of information to find T1 and D. Okay, so let's see how we can do that. So number 3. So term number 6 is T6. We are given that is 21. In terms of T1 and D, term number 6 is T1 plus 5D. So T1 plus 5D, we are told this is equal to 21. So, and then the sum of the first 17 terms, so that is S17. In terms of T1 and D, that is 17 over 2 times 2T1 plus 16D, that is equal to 0, we are told. Okay, this we can actually, if you factorize the 2 here, it's going to cancel with that 2. Then we can write this as T1 plus 8D. So what we have here is two equations in two unknowns. This is the first equation, this is the second equation, and the unknowns are T1 and D. So got T1 plus 5D is 21, T1 plus 8D is 0. If we subtract these two, subtract the first one from the second one, 8D minus 5D is going to be 3D. 0 minus 21 is going to be negative 21. So this tells us that D is equal to negative 7. Then from the second one, T1 is negative 8D, so it's going to be negative 8 times negative 7. So T1 is 56. The question is needs us to find the first three terms. So if you say 56 plus negative 7, that gives us T2 to be 49. 49 plus negative 7, that gives us T3 to be 42. So we can see that the terms of this progression are just multiples of 7. All right. So that is that was number 3. What we're going to do now is we're going to go to number 4. In number 4, we're going to do 2 examples, and then we will give you 2 to do. All right. So we're going to start with number 4G. Okay. So number 4G, we have the following sum. Find sum of 90 plus 105 plus 120, and then all the way to 9,000. Okay. So the first thing I want to do here is just to work out the differences of these, and you're going to see that this is plus 15 and that's plus 15 there, so that's definitely an arithmetic sequence. So that means D here is 15. From this we know that T1 is 90, Tn is 9,000. The thing that we don't know is the number of terms. Okay. However, if we know T1 and D and Tn, we can find the number of terms using the formula for the nth term. Because in this formula, this is known, this is known, this is known, so we can find that. Okay, so that's exactly what we're going to do. So we're going to punch in 9,000 this side, so 9,000 here, 90 here, n minus 1, D is 15. Okay, then if we take 90 to the other side, so that's going to be 9,000 minus 90. Okay, so 9,000 minus 90, just punch that in the calculator. It's going to give us 8, 9, 10 is equals to 15 n minus 1. Then if we divide that by 15, it gives us 594. So n minus 1 is 594, which means n is 595. So that means the number of terms between 90 and 9000 inclusive is 595. So the sum we're looking for is S595. So since we know the first term and the last term, we can use the formula which uses T1 and Tn. T1 is 90, Tn is 9000. Okay, then if we punch this in the calculator, this is going to give us 2,704,275. all right, so that is going to be the sum of those terms. Just going to do one more example, then we'll give you some to have a go at. all right, so in example number 6, we have let's just read it. So in example number 6, I've got an application. So the first, second and third courses from the top of a step wall have 4, 7 and 10 bricks respectively, as shown in this diagram here. So 1, 2, 3, 4 here, 1, 2, 3, 5, 6, 7 here, and then 10 for the next one. The wall has a total of so that's first course, second course and third course. The wall has got a total of 38 courses, so going down like that. Find the number of bricks in course number 11. Find the course with 64 bricks. Find the total number of bricks in the whole wall. Okay, so this we are going to realize is an AP, because 4, 7 and 10 are separated by a common difference of +3. So that means we have as soon as that happens, then we know that we have an AP. Okay, so T1 is 4 and D is +3. So that means we can write a formula for the nth term. It's going to be 3n plus 1. So in part A, the number of bricks in course number 11 is going to be T11. It's going to be 3 times 11 plus 1. So that's going to be 34 bricks in course number 11. In part B, we want the course with 64 bricks. So if we start with this formula here, then this time we know the number of bricks is 64. Then we want to solve for n. So here 3n is going to be 63. So n is going to be 21, so it's going to be course number 21 has got 64 bricks. Then in part C, find the total number of bricks in the whole wall. So that's going to be a sum, and we've been told that the whole wall has got 37 courses, so it's going to be S37. So that's going to be 37 over 2. 2 times T1 is 4, and then 37 minus 1 is 36. The common difference is 3. So, and then if we plug that in the calculator, that is going to give us 2146. Okay, so that's that. So let's just give you a chance now to have a go at these other examples as we mentioned earlier. Okay, so first we are going to give you a chance to have a go at number 1, part 7 and part 8, then number 2, then for number 3, let's see which one you are going to do in number 3. In number 3 you can do parts. You can do question. Okay, maybe let's create a question for you. So the last one is J. Let's call this one K. Okay, you're gonna do 100 plus 115 plus 130, and then all the way to 10,000. Okay, so that's the number 4. Then you're going to do number 5. Parents sets up a fund for their son, so just do the whole thing, and then when you, so I think you might want to just pause the video, have a go at all those, then when you press play, then you can compare with what our answers are going to be. All right, we're now hoping you have had a go at the exercise we gave. We're not going to show you our answers. If you still haven't, please do so before you scroll down. It's going to be more helpful if you look at these after attempting the problems yourself. Okay, so starting with number 1, part 7, we can see that T1 is -8, D is 9. So the formula for the nth term works out to 9n minus 17. Then plugging 55 into this formula gives the 55th term to be 478. Then the sum of the first 70 terms, if we plug into that formula, is going to be given by 21,175. For part 7, for part 8, the first term is -2, the common difference is -4. So the formula for the nth term works out to 2n minus 4n, from which term number 110 becomes negative 438. The sum of the first 100 terms is negative 20,000. In number 2, we're given that the 7th term, T7, is 41. We write that in terms of T1 and D. And term number 13 is 77. We write that in terms of T1 and D. Then inside the red box here, we've got a linear simultaneous system of equations. Solving that, we get T is 6, from which then T1 is 5. Question is looking for term number 20, so that one is going to be 119. Number 4K, the first term is 100, the last term is 10,000. Where from the first three we see that the common difference is 15. T1 is 100, Tn is 1,000. So and D is known, so from that we can find the number of terms in this summation is going to be 661. Then plugging into the summation formula, we get the sum of these terms to be 3,333,000. For number 5, the sequence of the deposits is an AP with difference 5 from 100 to 105, 110. T1 is 100, so the formula for the nth term is 5n plus 95. After 8 years, we're going to have 96 months. So that term is going to be T96, which is 575. So that's going to be the deposit at the end of 8 years. And then the deposit that is 800 is going to happen after 141 months, which is 11 years, 9 months. The total deposited after 21 years, it's got 252 months. So it's going to be S252, and that is going to be 366,660. All right, thanks for watching. Please subscribe so that you can get notified whenever we post new videos. Thank you very much.